Hey folks, welcome to this episode on drawing covalent structures. In this episode, we are looking at drawing BH3. Now, this one's going to require a little bit of an exception that you should have remembered from a previous lesson. Let's start off with how many electrons or valence electrons these atoms are coming in with. So step number one, we have B, we have H, we have one of these and three of these from our equation. Now, boron, when we look at boron, boron is in group number 3. So it's going to have 3 valence electrons. And hydrogen is in group number 1. It's going to have 3 in total. Let's add these. We have 6. Okay. Now, here's where the exception takes place. Remember that boron is one of those things that has an exception. It doesn't actually need 8 valence electrons. It only needs 6. So we need to make sure that we account for that exception in this particular step. Hydrogen needs 2, so we'll put 6, and we'll have 6, and we have 12. Okay, so that's one massive exception that we have to remember when it comes to boron. Step 3 is the same as before. We'll take 12 minus 6 to find that we have 6 shared electrons. They share in pairs, which will give us 3 sticks. Now that makes sense. There are 3 hydrogen atoms that would have to connect to boron, and so we need 3 sticks. And then finally, we'll see if we have any electrons left. We start off with 6 from step number 1. We use 6 electrons in step number 3. And so that will give us 0. So we have 0 lone pairs. All right. All right. So again, to figure out where all these numbers are coming from, this is how many we had to begin with. We use this number over here, and we also use that number over here. We found that we would need 12, and so we use that number over here. And to figure out how many we were sharing, we found that we had 6 that we were sharing. And since we were using 6 to share, we had no lone pairs at the end of the day. To figure out which atom is going to go into the center, we see which one has the most unpaired electrons. Boron being in group 3 have 3 unpaired electrons, and hydrogen being in group 1 only has 1 unpaired electron. So boron's going to go into the center. We're going to put boron here, and again, treat the area around boron as a 360-degree circle. We have 3 hydrogen atoms that we need to place, so 360-degree circle divided by 3 is going to be 120 degrees. So we're going to put them as 120 degrees apart from one another. Start with one at the top, 120 degrees away, and 120 degrees away, we get this kind of structure. Again, without looking at how many sticks we have, we just need to bond these to the center atom, just like that. And so we will have BH3. We've used our sticks. And then let's look at how many lone pairs we have. Oh, we actually don't have any lone pairs. We are done our structure. And that's it. That is our structure for BH3. Most important thing here is to remember the exception and account for it in our second step because we don't actually need 8 valence electrons for boron. Hopefully you found that helpful. Thanks for tuning in. Tune in again for more examples of Lewis structures.